If you're solving an equation by factoring.
Let it all equal 0.
Set it all equal to 0, exactly, right. So what we're going to do here is I'm going to write down, you have 2x squared plus 5x equals 3 minus 2x minus 4x squared. So you need to make it equal 0, so you need to clear one of the sides. So I'm going to add 4x squared to both sides. I'm also going to add what? 2x. End up with 6x squared plus 7x equals 3. But then what do I need to subtract from both sides? What do I need to subtract? 3. So I end up with 6x squared plus 7x minus 3 is equal to 0. Now, the leading coefficient in this case is what? 6. You don't like that too much because it isn't 1. You have to test a few things. But if you break it apart, it is going to come out to be 3x and 2x. And then you just have to test things. You have to test things until you get the right one. It's going to be 3x minus 1 and 2x plus 3. If you test that one, it does work. I'm just telling you it does work. So if that's the case, what is the OR statement?
3x minus 1 equals 0.
Or?
2x plus 3 equals 0.
Exactly. So 3x is equal to 1, so x is equal to?
1/3.
Or 2x equals negative 3, so x is equal to negative 3 over 2. There's two answers to that, and there they are right there.
Can we go over one of a division problem?
Okay, so there's a missing power there. What's missing?
Second.
The second. So what you need to do is, you can't change the overall value. Oh, it's minus what? 4 what?
4k.
You can't change the overall value. What's the only thing you can add to something? What's the only thing you can add to something? 0, exactly. So I'm going to take this right here, move it over, and what am I going to put there? 0 what?
Squared.
0k squared, exactly. What's the leading term underneath the division symbol? So you do 9k to the 4th over what? 3k squared, and what's that going to be? 3k squared. It's just leading, so you do 3k squared, and then what do you do once you have the 3k squared there? So you end up with 9k to the 4th minus what? 3k squared. Now in this case, where do you put it? It shouldn't go under the cube. Where should it go?
Under the 12k cube.
Well, it's squared. So remember, I told you many times you must put the parentheses around. So if you subtract this, what happens to the 9k to the 4th? It cancels out. It's gone, right? We'll move this over just a little bit. So these are gone, but then what happens to the 12k cubed? Oh, nothing, because there's no k cubed term, right? What is 0k cubed minus negative 0k squared minus negative 3k squared plus 3k squared? What's the leading term now? 12k cubed. It's the first one. Distribute the negative. That's why the parentheses are so important. What's the leading term now? 12k cubed over 3k squared is equal to 4k. So we put that up here. And we take that 4k and multiply it by everything that's in the front. So what do you end up with? 12k cubed minus what? Minus 4k. We subtract, and what do we get?
The 12k cancels out, and that also cancels out.
It also cancels out. 3k squared. So what's the leading term now?
3k squared.
3k squared over what? 3k squared is equal to? 1. So this becomes plus what? Plus 1. And we multiply and we end up with 3k squared minus 1. You subtract, and what do you end up with? 0. So what does that tell you about the division? Perfectly said. It goes in evenly. So this tells us, everybody, this tells us that 9k to the 4th plus 12k cubed minus 4k minus 1 over 3k squared minus 1. What does that tell us that equals? Nope, 3k squared plus 4k plus 1. That's what it tells us. That's what it tells us. This one's nice because what's the remainder?
0.
Is the remainder guaranteed to be 0? No, it's not.
How do you write the remainder?
You would just say remainder. Oh, wait, this would be the remainder. You just say, if I asked you, hold on, no, if I asked you what the remainder is, you would say the remainder is 0.
And what if you had a remainder? How do you write it?
It's plus 0 over 3k squared minus 1. But what is 0 over anything? 0. Oh, 0 over 0 isn't 0, but 0 over anything besides 0 is.